We're looking at similar triangles. There's three conditions, or three types. Two angles could be congruent. All three sides could be proportional. Or two sides could be proportional with the angle in between being congruent. So angle-angle similarity is pretty obvious, so I'm not going to define anything. Let's actually use this right here. So do we all see the tick mark, the single swing right here? That means they're congruent to each other. What else is congruent to each other according to last semester? Vertical angles are always congruent. So again, according to angle-angle similarity, I only need two sets of angles to be congruent. So this one would be yes. In our similarity statement, triangle, XYZ. Now, how you start doesn't matter, but how you name the next triangle does matter. So how should the order be from XYZ on the other one? M and Z, very good. And this is by angle-angle similarity. Not angle-angle congruency. Okay, we're not looking at unit 4. Part B, how many triangles do you see? I see a smaller one and I see a bigger one, right? When they're overlapped, always separate them. So here's my smaller one, and here's my bigger one. Let's also name it to be consistent. Smaller one is ABE, and the bigger one is ACD. And let's notate what is understood. If two lines are parallel, what do I know about corresponding angles? They're congruent, so I can go to the corresponding on the separated figure and put the congruent to. What's been shared between both of them? You see angle A is the same on the small one and the big one, so we know they are congruent. What property was it, if you remember? When you look in the mirror, it is yourself. Reflexive property. Does someone say transitive? No. So we have triangle ABE. How should I name the other triangle? ACD. And that's by what similarity? Angle-angle similarity, not reflective. Let's find the unknown angles on part C. If I have angle B is 70 and A is 30, what must be angle C? 80. Then if for the other one, 80 plus 20, so this one has to be 80. Now, do I have two sets of angles that are congruent just by looking at this? No. I know I have the 80, but where's my second one, right? So no, they're not similar. Boom. For side similarity, the corresponding angles must be proportional, then they are similar. And I'm going to give you an example. Draw me a big triangle on the left and draw me a smaller on the right. And let's say I have 4, 14, and 8. Clearly figured, not drawn to scale, right? 2, 4, and 7. Look at all the sides. Are all the corresponding sides proportional? Yeah. What is my scale factor from left to right? Ooh, left to right. 1/2. Good one. If you said 2, I get it. You went from right to left. So with the partner, let's decide on, are they similar? Go.
Yes. 1/2 once again.
Hopefully the first one is a yes. They're both yes. Do you see this figure has been rotated and shrunk? So what I would do is I would redraw this figure. And by that I mean I'm going to keep the smaller one as it is. And then I would redraw the big one. So then it's in the same position. That kind of helps. So we know my short side is 6. Long side is 9. And our diagonal over here is 12. So are they similar then? Yep. So we have our last similarity, side angle side. So let's go to the back when you're ready. Go into the back. All right. So we know one angle must be congruent to another angle of another triangle. And then the lengths, oh my, of the side, including the angle, is proportional. Then we know the triangle is similar. If the wording was kind of confusing, I'm going to give you a visual. So don't let the wording bother you. Give me two triangles. Could be big to small, small to big, doesn't matter. Let's say I give you the angle measurement of 70 for both the corners. And then I have 3 and 6 and 1 and 2. So I'm going to restate the theorem. The angles are congruent, true? An included side must be proportional. 3 to 1, 6 to 2, they are proportional. Then it must be similar. That's all that it's trying to say. So I like the image better. It makes a lot more sense. So let's go ahead and apply that on part A. What should I do with the triangles here? Separate. So I'm going to put the smaller one on the left, the bigger one on the right. So I have 3 and 5. And then I have 5 and 9 because whole thing added. By reflexive property of congruence, is that corner angle congruent? Yep. So we have the angles are congruent, and let's look at the side. 3 to 5 and 5 to 9. Are they proportional? Nope. Okay, put a big star on this one. And I want you to write the following. This is a twisted triangle. And twisted triangle basically means this 3 is corresponding to this 9, and this 15 is corresponding to this 5 because it's been twisted. Okay? So let's see if I have an angle that is congruent. What angle is congruent? Vertical angles are congruent. Is that right? Now, it's twisted, so 3 to 9 is 1 to 3 ratio. 5 to 15 is what to what ratio? So are they proportional?
Yeah.
So we know we have yes. Triangle, I'm going to say FED. Oh, I said E and I wrote D. FED is similar to triangle. How would I order the next one? It is twisted. FGH, very good. And that is by not side angle side congruence, but side angle side similarity. Now, see, we don't even have to look at. Look at the first image. Is that even side angle side? Side angle, right? So I don't need to compare at all. Nope. Okay. On the bottom, I want you to scratch off the questions, and I want to only worry about notations on the right. That is all you need, okay? So here I go. If two lines are parallel, then I know corresponding angles are congruent, and the other corresponding angles are congruent. And because I have a triangle that is overlapped, what must be congruent to itself? A. That is all I want you to grasp. If you're good with that, give me a thumbs up. Good? Okay, let's go on to our last one. Let's try this with the partner, and I'm going to chime in. Go. I would separate it first. We're working together. Right, Chase? Together. You're like, leave me alone. I got this. You do. Mm-hmm. Okay, I'm going to give you a pointer. When you separated the big triangle, hopefully you wrote the 24 instead of x plus y. Why make your life miserable and write x plus y when you can simply write a whole number. Okay?
No. I'm gonna text his mom and ask him. Oh, there is. You're not going.
Did y'all get x equals 16? So if x equals 16, how many is my y? 8. So I'm going to kind of go backwards. How do I even know that these two triangles are similar when it's not stated?
Because they have the same age.
Because if two lines are parallel, corresponding are congruent, these corresponding are congruent, and if you don't want to use that corresponding, reflexive. All good? All right.